Hi everyone, welcome back to my channel Lila WebDev. In this video, we will try to learn about the understanding HTTP sessions and the tokens. This presentation explores how HTTP stateless nature works and why it is beneficial for scalability and how we use the sessions and tokens to track user across the requests. We will walk through the entire process from login to authentication, covering the basic practices, best practices and security considerations along the way. So let's proceed further. Let's open this one full screen. Okay. So what is stateless HTTP? So first of all, you need to understand what is HTTP, stateless HTTP. So HTTP is stateless. What does that mean? It means that every request sent from a client to a server is treated as a completely independent event. The server doesn't remember anything about the previous request, even if they came from the same client just seconds ago. So that is called as an stateless HTTP. For example, let's say that client 2, or let's say that we are having client 2, client 4, client 5 like that. So let's say the browser 1, browser 2 like that. So browser client 2 has sent a request to the server 2. So each request will be handled independently. So immediately the client 4 sends a request to server 1. Server has no memory of previous request. Client 4 sends again request to server 2. Server 2 has no idea about the previous request. So like this, the servers doesn't store any data related to the client's information. So every request is an independent to each other and it will try to access it. Even if thousands or millions of requests flying around, they are all processed without any memory of each other. This is what it makes the HTTP stateless. So why stateless is great for scalability? So this is the main thing. So why? Because so now we are able to understand that HTTP is then stateless. So that means every request is independent to each other. So why it is that statelessness is great for scalability means. So now you might be thinking why the HTTP has designed this way. Well, statelessness is actually awesome for scalability because servers don't need to remember past requests. We can easily add more servers to handle the traffic when the demand is high, or we can shut down some shutdown. We can shut down some servers when it is low. So that is the main thing. So the servers, there is no need to maintain the records of the previous request or anything. Each request is independent to each other, right? So how many servers we want, we can start the server when the demand is high, and we can shut down some servers when the demand is low. This flexibility lets us scale our web apps efficiently, and statelessness is the key to unlock that power. Then what about the login and user data? So whenever the user logs in and he asks for the user details or something like that, so the server doesn't store any information regarding the previous request, right? How can the server can able to understand that the user is logged in? So here the problem we will try to deal. The statelessness challenge is the statelessness can be a problem for certain features like user login. Let's say that imagine a user logs into your website and in their next request they want to fetch their profile info. How does the server know it is the same user? So this is the problem we will be coming with the statelessness. Server confused. Since HTTP is stateless, the server has no clue who has sent the request. So feature limitation. Without some way to track the user, features like login, shopping carts, or even saving user preferences like switching a website to dark mode wouldn't work. So this type of things wouldn't work. So how we can solve this one? So for this reason, we will be introducing the sessions. So introducing the sessions. To make the HTTP stateful, we introduce the sessions. So let's focus one client, say, so let's say client 4 and walk through how sessions work. In our real world, we also have a database which stores all our data like user info, posts or sessions. So we normally in the real world will have a database. So it is also one type of server where our data will be stored. If you are new to database, don't worry, just think of it as a big storage unit of all your apps data. Now let's see how client 4 logs in and how we keep track of them. So the login process, how it will be, client sends a request, login request. That means client 4 wants to log in. They send a request with their username and password to our load balancer, which is just an HTTP proxy, which we have seen in our previous videos, that routes traffic to one of our servers. Say server 1, it has been routed the traffic to it. Now server 1 gets the request, checks the username and password with the database and confirms that they match to each other and the user is authenticated. Server 1 then sends a response back to the client saying you are logged in. Now the stateless is problem, right? But here is the problem. If client 4 sends another request, maybe to server 2 to fetch their profile, server 2 has no idea that client 4 has just logged in. Why? Because HTTP is stateless. So then how we can connect these dots? So now Now the client 4 has logged in. Now if he is asking the profile information or something like that, means so server 2 doesn't have an idea that the user is logged in already. So how we can solve this problem? Let's see. So the solution for this one is the tokens. So this is where tokens come in. Token is like a digital ID card similar to a student ID at a university or a badge at work. When you first join a company, you show your government issued ID, they verify it's you and they give you a badge with unique code. Later you tap that badge to access the buildings and system knows it you, not because your full information is the badge, but because the code matches within the system. So something like it is a student ID card with a secure data, so that if you tap it or something like that, it can scan your entire information, right? Something like the token is also the same thing. We do the same thing here. When client 4 logs in successfully, server 1 generates a unique token, just a random string of characters. It saves this token in the database in a new table called sessions table along with the user ID. For example, it might say this token belongs to user ID. Server 1 also sends this token back to client 4 in the response. Client 4 saves the token on the device, either in memory or in disk. Now they are ready to make more requests. So using tokens for the future requests. Let's say the client sends request with the token. Client 4 wants to fetch their profile. They send a get request to profile and include the token in the request. Usually we will be adding the token in the headers, not the body, because headers are a common place for session related data. Now the database checks the session table and says, yep, this token belongs to the user ID 1. It then looks up the user ID 1 in the users table and grabs their profile data like their name, username, and sends it back to the server 3. Now here, the second step, what will happen is load balancer routes the traffic to server 3. These all things. So step 4, what will happen is, so now it has given the sends it back, right? Server 3 sends this profile data back to the client 4. Boom. Just by including the token, client 4 was able to authenticate themselves and server 3 knew exactly who they are, and that's a session in action. So now why tokens work? Uniqueness. The token should be unique. No two users should have the same token, just like no two people get the same email address. The token is stored in both client's device and your database also, so we can match them up. Consistent inclusion. The client includes the token in every request, allowing any server to identify them. This is just for logins. With the sessions, you can implement shopping carts, save user preferences like light or dark mode, or track anonymous users without requiring a login. So token security and best practices. So this is also one of thing. Uniqueness is critical. If two users have the same token, it would like sharing an email address, total chaos. Security is a must. Tokens need to be hard to guess. You want a system with billions of possible combinations to prevent hackers from generating a valid token. Logout functionality. When the users log out, you delete the token from their device and also remove it from the sessions table to invalidate it. And yes, if someone steals another user's token, they could authenticate as that user. That's why token security is a big deal, but we will cover this in the future video on cryptography. So why not rely on the TCP? So the TCP is a connection, right? So that it will maintain a connection, right? Why not we rely on the TCP? You might be wondering, wait, is it TCP stateful? Can't we just use the TCP to track the clients? TCP does keep track of connections between a client and server, but it is not reliable for sessions. Why? So if you are relying on TCP to identify the user, you would lose their session. Network changes, IP address shifts, or connection timeouts can all disrupt TCP. So it's not a stable way to track users. Tokens on the other hand persist across connections. Saving tokens in a web browser. One last thing, how does a client save the token? If the client is a node.js app, it can save the token to a file and include it in the future request. But if the client is a web browser, means which is super common. So how do we tell a browser to save a token and include it in every request? So let's say the stateless HTTP doesn't remember requests between connection. So sessions allows to track users among multiple requests, and tokens unique identifies that connect users to their data. So to wrap up, HTTP is a stateless, meaning that it doesn't remember requests, but by using sessions and tokens, we can make it stateful, allowing us to track users for logins, shopping carts, and more. We generate a unique token, store it in the database and in the client, and use it to identify users in the future requests. It's simple but powerful. So if you found this helpful, give this video a thumbs up, share it with your friends, and let me know in the comments if you have any questions about sessions or HTTP. Don't forget to subscribe for more web dev tutorials, and I will see you in the next video where we tackle tokens in the browsers. Thanks for watching and happy coding. Thank you.